Hi everyone, welcome back. So in the last session, we were discussing data hazards. We have taken two examples and I told you uh, uh, which dependencies are hazards. But anyway, so let's discuss everything in detail. So far, we did not see these things in detail. I just gave you two examples just to explain the concept, but now let's see all the things in detail. Okay, so first we will start with the data dependency and data hazard. What is the difference between data dependency and data hazard? So let's start with data dependency first. First we will see data dependency. So forget about hazard. Okay, just focus on data dependency only. Now, let me tell you that data dependency is only the property of code. Okay, this data dependency, this is property of only the program, not of the pipeline, not of the processor. Okay, so remember, this is property. Please understand that this is property of code only. This is property of your program only. So this is a property of code only, nothing else. Okay, so this does not depend on the pipeline. So remember, this data dependency, this does not depend on the pipeline. Okay, it does not depend on the pipeline. So it has nothing to do with the pipeline. Does not depend on pipeline. It is purely a property of code. Okay, so it is purely property of code. It will only depend on the code. So tell me one thing, if I give you the details of the pipeline and also I give you the code and then I ask you data dependency, will you consider the pipeline details? Will you consider the pipeline details? Are you going to confuse in the pipeline details? No, the answer will depend only on the code. Okay, so remember, this data dependency, this is the property of code only. This is the property of program only, nothing else. Okay, this is the code that you are writing, the program that you are executing. Okay, so this data dependency is the property of program only. Now let's take some examples. Consider a simple example. You consider that, let's assume that you have a register R1 and you are writing into register R1, you are writing R2 plus R3. Okay, and then let's assume that you are using register R1 in the next instruction. So this is your instruction I1, this is your instruction I2. Okay, in the instruction I2, let's assume this is what is happening, R4 and plus something. Okay, so now you can notice that this is a dependency. Can you notice that this result you will use here, right? Yes or no? This result you are going to use here. This result that you have, this result R1, you are going to use in the instruction I2. Okay, so I can say that this I1 I2. Okay, between I1 I2, there is a dependency. There is a data dependency. Okay, we have data dependency between I1 I2 because this value that you are reading, I2 is reading R1, which is written by I1. Okay, remember this instruction I2 is reading R1, which is written by I1. So there is a data dependency. You have a data dependency between I1 I2. We have this type of dependency. This is called read after write dependency. Okay, this type of dependency, look at this dependency. This type of dependency is called read after write dependency. Okay, after write dependency. Why? The reason is on your in front of you. This is called read after write dependency because the read must happen after the write. Yes or no? Because the read must happen after the write. The read must happen after the write. Okay, yes or no? Do you agree that this read must happen after this write? Can this read happen before this write? Can you read R1 before this I1 will write R1? Can instruction I2 read R1 before instruction I1 is writing R1? Can you do that? Okay, no, you cannot do that, right? So you can see that this is called read after write dependency. What is the reason? Why it is called read after write dependency? This is called read after write dependency because this I2 read, this I2 read, okay, I can say because this I2 read R1 must happen after I1 write R2. Yes or no? Correct. I1 write R1. So you can see that this read must happen after this write. Okay. This read must happen after this write. So that is the reason this dependency is called read after write dependency. That read must happen after the write. Okay. Is this clear? Another name of this dependency, let me tell you, the another name, either you can call it RAW dependency. The another name is called flow dependency. The another name is flow dependency because this is the flow of the program. Yes or no? This is the user program and this is the flow of the program. Correct? This is the user program, right? Yes or no? So you can notice this is the user program and this is in the flow of the program. This data is flowing from here to here. See, this value is flowing from here to here. So this is called flow dependency also. This RAW dependency, this is also called flow dependency. This is also called true dependency. This is also called true dependency. Why it is called true dependency, I will tell you after some time, and your mind will be blown. Like you will find it awesome. Okay, why it is called true dependency, I will explain after some time. But these are the different names of this. Okay, is this clear? Did you understand what is this dependency? Now tell me another question I am asking. Let's assume that you have R1 here, and another instruction you have, that is R5, and then you have R1 plus something R6. Okay. And then you have, let's assume. Okay. So let me give you something more. Then you are writing into R1. Okay. Then you are writing into R1. You are writing into R1. And then again, you are reading R1. Okay. So now you tell me how many RAW dependencies we have in this program. How many RAW dependencies? I am asking how many RAW dependencies in this program. How many RAW dependencies we have? Program is given to you and the question is asking how many RAW dependencies we have in this program. So you can notice that in this program, this RAW dependency we have. Okay. So this RAW dependency we have. So I can say that between I1, I2, there is a RAW dependency. These are the RAW dependencies. I am writing all the RAW dependencies that you have this RAW dependency because this read must happen after this write. Okay. Or I can say you are reading the value which is written by I1. Yes or no? I2 is reading the value which is written by I1. Okay. Now, what about this? Is this RAW dependency? Tell me. Is this RAW dependency? Is this RAW dependency? Please tell me. This is I3, I4, I5. Okay, this is I3, I4, I5. So tell me about this one. So tell me, is this row dependency from between I1, I3? From I1 to I3, do we have RAW dependency? Yes, because again you can notice that I3 is reading the value which is written by I1. This I3 this depends on I1, correct or not? Tell me, are this instruction I3, does it depend on I1? Instruction I3, does it depend on I1? Yes, it depends on I1. So you can notice that it clearly depends on I1 because you are reading the value which is written by I1. Okay. Now you can notice, what about this one? Is this RAW dependency? Is this RAW dependency? Tell me. Look at this one and tell me, is this RAW dependency? Yes, this is RAW dependency. Yes, this is RAW dependency. What about this one? This is not RAW dependency. Why? What is the reason? Tell me, what is the reason? So remember I1, I5, this is not RAW dependency. This is RAW, this is RAW. Why this is not RAW dependency? Because remember, this I5 does not depend on I1. I5 does not depend on I1. I5 depends on I4. Okay. Remember this point. I5, this instruction does not depend on I1. This instruction depends on I4. So remember this I4, I5. This is RAW dependency. Okay. This is RAW dependency. So, but this is not. So because you are writing in between this I4 is writing into R1. So you can notice this dependency is not there. You don't have this dependency, but yes, you have this dependency. So finally, total 3 RAW dependency we have. Is this clear to everyone? Please tell me. Okay, clear? Okay, now Debanjan is asking that, sir, if I4 was R99, yes, then it will be, of course. See, if you do this, if you remove this, if you don't write in between, and let's assume you have this situation, you have something in R99, yes, then there is no problem. Then this is a dependency. Okay, then you can notice, then this will be dependency. So in this situation, these are the RAW dependencies. Okay, is this clear, Debanjan? Okay, any other doubt? Okay, so let me give you the definition of RAW dependency from the Washington University. Okay, from the Washington University. This is the Washington University slide. This slide has been taken from Washington University, and let me give you the definition. You can read the definition of RAW dependency. So what is the dependency of RAW? Read the definition. What this so this is saying that between instruction I and J, you have this dependency. There is instruction I that is writing. Remember the instruction I, and there is instruction J. There is instruction I, there is instruction J. This instruction J is reading what this is writing. Okay, what this is writing, this is reading. So what this is writing, this is reading. In between, there should be no instruction which is writing. In between, no one should write R. Okay, no one should modify R. No one should write R. Is this clear? Tell me. Look at the definition. Is this definition clear? That in between, no one should write into R. Then this dependency will be called RAW dependency. Please tell me, is this clear? Let me know. Clear or not? Very simple, right? This is the definition of RAW dependency. Very simple. Okay, in this, how many RAW dependency we have? Like, let me give you instruction I1, where in instruction in register R we are writing, and then in instruction R2, let's assume you are doing this R plus R. Now tell me how many RAW dependency? How many RAW dependency? Can I say answer will be 2? Can I answer will be 2? Can I say the answer will be 2? No, answer will not be 2, because dependency is between instructions. Dependency is defined between instructions, not between registers. This register does not matter. This register does not matter. The dependency is defined between registers. Is this clear? Okay. This dependency concept basically, this is defined between what? This data dependency concept. This is defined between, or I can say this data dependency happens between instructions. Okay. Data dependency happens between instructions. So this data dependency, this happens between instructions. So in this, remember, in this there is only, so in this only one RAW dependency you have. And what is that? There is only one RAW dependency, and that RAW dependency is from I1 to I2, or I can say between I1, I2. Clear or not? From I1 to I2 or between I1, I2. So there is only one RAW dependency here. Okay, because dependency, this data dependency happens between instructions. Is this clear? Dependency exists between instructions. Okay, clear or not? So very simple. So this is your concept of RAW dependency. Now let's see the another concept, that is WAW and WAR dependency. Now let me tell you, consider this situation. Again, you have instruction I1, and where you have, so let's assume that it is reading. Okay, you are writing something into it, like you are writing into R1, something you are writing into R1, and then again you are writing into R1. So this is also writing into R1. Now you tell me, just a simple point I am asking. Okay, you tell me, are they dependent? These instructions, are they dependent on each other? Are they dependent on each other? Yes, they are dependent. Why? Because no, they are dependent. Why? They are dependent because just think about it. Arey, think about it. If they are not dependent, then can you reorder them? If they are not dependent, can you reorder them? If they are not dependent, tell me, can you reorder them? A very simple point. The future people should read this. Okay, the future people should read this. If you reorder them, then the future people will read this. Yes or no? If you reorder them, then the future people will read this. Okay, the future people, the future instructions, these are the future instructions. Okay, so you can see that. So very simply you can see that they are also dependency. Here also you have a dependency. Here also we have a data dependency, but this data dependency is called output data dependency, because basically this output should be visible to the future instructions. Okay, yes or no? This output should be visible to the future instructions, not this output. Okay, this output should not be visible. So that is the reason this is called output data dependency, or you can call it what? Or you can call it write after write. Means this write must happen after this write. Yes or no? Is this clear? This write must happen after this write. So this is also called WAW dependency. Okay. Now let me give you another example. So what is WAW dependency? Let me give you the general definition. The general definition of WAW dependency. When this happens, okay, when this happens, like this is I1, and this is this is your instruction I, and this is your instruction J. Let's assume this is the instruction I, this is the instruction J, and this is writing. Now remember, this is WAW dependency. If and only if what should not happen? Tell me. Arey, what should not happen? Tell me. In between, no one should write R. Yes or no? So you can notice this will be WAW dependency. This will be WAW dependency, but in between no one should write R. Okay, in between no instruction writes R1. Clear? In between no instruction should write R1. Okay, then in this situation we will say that there is a WAW dependency between I comma J. Okay, so for example, if you have this situation, like let's assume that someone is writing into R. Okay, then let's assume someone is writing into R, and then let's assume someone is writing into R. Then how many WAW dependency? Then how many WAW dependency? This is WAW, this is WAW. So remember, this is WAW, this is WAW, but this is not WAW. Okay, clear? Similarly, so there is another type of dependency. Look at, there is another type of dependency. Consider this situation that I1 is reading R1. Okay, and something it is doing, maybe. Okay, now let's assume I2, it is writing into R1. You tell me, are they dependent on each other? These two instructions, are they dependent on each other? Are they dependent on each other? Simple question I am asking, are they dependent on each other? Yes, they are dependent on each other, because just think about it. Can you reorder them? Just think about it. Can you reorder them? You cannot reorder them, because this I1 should read before I2 writes. Yes or no? This I1 should read before I2 writes, or I can say this I2 should write after this I1 should read. This must happen after this read. So there is a dependency here. There is a dependency here, and this is your write after read. Means you do the write after this read. Okay, you do the write after this read. So this is your WAR dependency. Means you write after you read, after this I1 reads. So first this I1 should read, then this I2 should write. So this is called WAR dependency. The another name of this is anti-flow dependency. This is anti-dependency. This is another name is anti-dependency. Can you see why this is anti-dependency? Can I see this is why anti-dependency? Because your flow dependency is like this. Your flow dependency like this, and this is like this. It's reverse flow, something like that. Okay. So this is not like a big thing, but this is called anti-dependency. The reason this is called anti-dependency is because this is just opposite of the natural flow. This is the opposite of the natural flow. Like this is the natural flow. This is the flow dependency. This is the flow dependency. Okay. So this is the opposite of the flow dependency. So that is the reason this is called anti-dependency. Okay. So again, you can notice that, if you have instruction I and there is instruction J, it is reading something, okay, and it is writing into R, then this dependency will be there. There will be a WAR dependency. You can notice there will be a WAR dependency. What should be the condition? Tell me. What should be the condition? In between, no one should write R. No instruction writes R. In between, no instruction writes R. Okay, very simple. This is your WAR dependency. Now let me tell you something interesting. Let me tell you now. Okay, see these two dependency. If you, okay, something very important I'm telling you, very important I'm telling you. There are two pipelines, correct? So far, did we discuss pipeline? When we are discussing dependency, did I give you the details of pipeline? Do we care about the pipeline? Do we care about the pipeline? No, we do not care about the pipeline, right? But ultimately, this program, this code will execute on the pipeline, right? Yes or no? So because of these dependencies, can there be some problem on the pipeline? These dependencies do we have? Yes. In our program, we have these dependencies. You have the program, okay? In that program, you have these dependencies. You have RAW dependency, WAR dependency, and you have WAW dependency. Okay, so in your program, you have these dependencies. Now you tell me, when you execute this program, which has these dependencies, in your program, you have flow dependency, output dependency, anti-dependency, all the dependencies you have. When you execute this program on the pipeline machine, then it is possible some problems can happen. Agree? Yes or no? It is possible some problems can happen because of these dependencies, because instructions are dependent. So some problem can happen. Okay. If problem happens, then these dependencies will be called what? If some problem happens, then these dependencies will be called what? They will be called hazard. Okay. If some problem happens, then these dependencies will be called hazard. Okay. If no problem happens, then these dependencies are not hazard. So these dependencies will be hazard if some problem happens, and these dependencies are not hazard if problem does not happen. Okay, so very simple point. If problem happens, then hazard, then these dependencies will be hazard. If problem does not happen, then these dependencies are not hazard. So a very important note I'm telling you, in our syllabus, which type of pipeline you have, let me tell you, like after some time I will give you the there are two type of pipeline. Okay, something I'm telling you, there are two type of pipeline. We have total two type of pipeline. There is one type of pipeline which is single issue, and another type of pipeline is which is multiple issue. There is one pipeline which is single issue, which is another is multiple issue. Single issue is what we study. This is what we have studied. This is what we study. So what is single issue? The name itself is telling you single issue means only one instruction can input. Okay. In every cycle, how many instructions you can input? Tell me. In any cycle, how many instruction fetch you can do? How many instructions you can fetch in any cycle? How many instructions you can fetch? Only one instruction you can fetch, right? So that is called single issue. Single issue means in the instruction fetch, only one instruction you can fetch. Okay, isn't it simple? This is what we have seen so far. This is what we study. This is natural, that instruction fetch, only one instruction you fetch. This is called single issue. Multiple issue, what happens? Multiple issue means you can fetch many instructions simultaneously. Okay, many instructions you can fetch simultaneously. I1, I2, I3, I4, right? Is this clear? Okay. Many instructions you can fetch simultaneously. Many instructions you can execute simultaneously. Many instructions can decode simultaneously. Are you getting my point? Are you getting? Is this clear? Like many instructions can execute. Many instructions can execute simultaneously. I1 is also using the ALU. I2 is also using the ALU. I3 is also using the ALU. Okay, in the same cycle, they are using the ALU. So this we don't study, right? Yes or no? Correct. So we study this. This is in our syllabus. Okay, this is in our syllabus. By default, I can say this is what we mean. When I say pipeline, this is what we mean in our syllabus. Or I can say by default, this is the by default, every pipeline is single issue. Okay, this is the default. This is the default. Okay. There is another point, that is in order, out of order. See, uh, okay, actually, that's it. See, I after some time I will tell you. After some time, okay, is this understood? Single issue, multiple issue, understood? Is this understood? That multiple issue means multiple things are happening. It's like you have many ALU. Just think about it. You have many ALU. You have 4 ALU. Okay. So this is also I1 is also using ALU, I2 also using ALU, I3 also using ALU. You have 4 ALU. Are you getting my point? Is this clear? So this multiple issue and single issue, did you understand? Very simple. Okay. In our syllabus, we have single issue. Single issue means one instruction you can issue. One instruction flows in any cycle. Only one instruction is in one stage. In any cycle, in one stage, only one instruction is there. In the execution stage, only one instruction can be there. Okay. So very simple. This is the concept. Now, okay. Now let me tell you that if your these are your code has these dependencies. These are the dependencies in your code. These are the data dependencies. What are the dependencies? These are the data dependencies like RAW dependency, WAR dependency, WAW dependency. These are the dependencies that you have in your code, correct? We have already seen. Because these depend only on the code. These things depend only on code. These are only on code. They depend only on code. Okay. Now you can notice, let me tell you something very important, something very, very, very important, that these people can never create any problem in our pipeline. Okay. They never, are you getting my point? They never create any problem. They never create any problem. They never create any stalls in our syllabus pipeline, or I can say in single issue pipeline. Is this clear? In single issue pipelines, clear or not? In single issue pipelines, they will never create any problem. These people are never creating any problem. You don't even have to consider them. These dependencies will never create I will prove it. I will prove it. See, this statement, I will give you the proof. I will give you the proof. Don't worry. I'm going to prove it that they will never create any problem. They will never create any stalls in our single issue pipelines. Basically, in our syllabus, whatever pipeline we have, okay, our MIPS pipeline, that is single issue, right? Our RISC pipeline, our classical 5-stage pipeline, that is a single issue pipeline, right? Okay, so these people, these dependencies, they can never create any problem. They can never create any stalls in our pipeline. Okay, so tell me, only these are the, yeah, only these can create. Only they may create. They may or may not, again, they may or may not. Okay, only they may create stalls. Only they may create stalls. Okay, only they may create stalls. Is this clear so far? So far clear this point? So that is the reason only row hazards are possible. These hazards are never possible. So remember, in single issue pipeline, if you have single issue pipeline, which is our default pipeline, like I can say, it's like I can say this is what we have in the syllabus. Okay, basically our syllabus pipeline. I call it syllabus pipeline, right? Okay, syllabus pipeline. So anyway, you can notice that. So in single issue pipeline, whether it is RISC pipeline or whatever, in any single issue pipeline, you have any single issue pipeline, we have no WAW hazards. We don't have these hazards. We don't have WAR hazards. Okay, these hazards we don't have because these dependencies are never creating any problem. Is this clear? One more thing, interesting thing, even if you have multiple issue pipeline, okay, like multiple issue means multiple instructions you are fetching many instructions in the same cycle. You are fetching 5 instructions. Okay, you are executing 5 instructions. Okay, in the same cycle 5 instructions are using the ALU. In the same cycle 5 instructions are decoding. Okay, so basically if you have multiple issue pipeline, then also let me tell you something interesting. What is that? Then all of them can create hazard. Yes. Okay, then all these hazards are possible. All these dependencies can create, problem. Okay, then all these dependencies, they can create problem, hazards possible. But something interesting, these hazards can be terminated, eliminated 100%. Okay, I will tell you very beautiful technique and you will love it. And you already know how to eliminate these. I will just tell you the name of it. Have you studied SSA in compiler design? I taught you SSA, single static assignment. Did you study that? Okay, so just remember it. Something interesting will come at the end. And there is a gate question on it. And no one knows the proof. You will know the proof. Okay, there is a gate question. Everyone by hearts it. Okay, but you will know the proof. I will give you, don't worry. But what I'm saying that these hazards can be 100% eliminated, using algorithmically. Okay, so algorithmically you can eliminate them. So did you notice these people are never a problem? Did you notice these poor people in single issue, they are never creating any problem? See, these poor people, look at these poor people, these two poor people. Okay, in single issue, they are never creating any hazard. In the multiple issue, they are creating hazard, but you can eliminate them. Okay, is this clear? So remember, these two are called false dependencies. So that is the reason. Final explanation. This is the final point I am saying, that this row dependency is called true dependency. This is the true dependency, and these WAW dependency and this WAR dependency, these are called false dependencies. These are just like, there is a dialogue, there is a meme. मैं सिर्फ दिखने में खतरनाक हूं, अरे ड्रो मत, मैं सिर्फ in the welcome movie, there is a meme. So these are the false dependencies. सिर्फ दिखने में खतरनाक हूं, do you remember? Okay, anyway, so I will send it to you. So this is the point. So this RAW dependency, these are called true dependency, and WAR dependency, these are called false dependency. So you can check WAR, WW, these are called false dependency, or you can say these are just name dependencies. Okay, why these are called name dependency? I will tell you, because just change the name and these dependencies are gone. See, these dependencies are called name dependency because just change the name and these dependencies are gone. Just change the name and these dependencies are gone. Just rename and these dependencies are gone. Is this clear? These dependencies are called name dependency because if you change the name, if you renaming, then these dependencies will be gone. So that is the point. Did you understand the complete explanation? Okay, you can check it out. In this question, tell me. This I give you as a homework. You can, the answer is here. Okay, you can check it out. So, understood so far? So far, did you understand? Dependency concept, did you understand? Any doubt so far? Anyone has any doubt so far? Let me know. Okay, so let's solve this question. Tell me quickly. So the question is asking, this is a Udacity from the Georgia Tech University. This question is taken. Okay, this is a course by Georgia Tech University. This program includes WAW, RAW, WAR dependencies. Show these. So tell me, how many RAW dependency? Let's check. First, let's check RAW dependency. How many RAW dependency we have? So you can notice this value you are reading. So this is a RAW dependency. You are reading this value. So from instruction 1 to instruction 2, there is a RAW dependency. So these are the RAW dependency you are reading. One. So this is your okay. So now what else? You can notice that This is also reading, right? Okay, here also you are reading. This is also reading. So you can notice you are reading here. So I can say 1, 2, 3. This is also RAW dependency because this value you are also reading here. But you can notice, is this RAW dependency? Tell me. Simple question. Is this RAW dependency? Is this RAW dependency? No, this is not RAW dependency because here you are writing now this is RAW dependency. So 3, 4 there is RAW dependency. Okay, 3, 4 we have a RAW dependency. What about this R8? Okay, this R9. Yeah, there is another RAW dependency, and that is 4 to 5. There is another RAW dependency. Total, how many RAW dependency? Total, how many RAW dependency we have? Just check it out. Total 4. So you can notice the answers are also given actually. So you can notice their total. Sorry, total how many? Did we miss something? Let's check. Did we miss something? R9, R3. Oh, okay. Look at this. See, this is also using because you are reading the data here. See. This in this instruction, we are not writing anything. Look at this instruction. Look at this instruction. In this instruction, we are not writing any register. Yes or no? In this instruction, what is this instruction? Tell me what is this instruction? B and E, branch if not equal. This is branch if not equal. Means if these are not equal, what this means? This means that if these are not equal, then go to L3. Clear? Is this clear? So you can notice we are reading R8 here. You are reading R8. See, please understand. You are reading R8. Okay, so don't miss this type of simple things. Okay, so is this clear? You are reading R8 here. So that is the reason. Finally, I can say there is 2 to 5. Okay, so there are total 4 RAW dependency. Understood? This question is covering all the, I can say all the silly mistakes where silly mistake can happen. So at this point, silly mistake can happen, right? Is this clear? Because here you are not writing anything. In this instruction number 5, you are not writing any register. You are reading R8, you are reading R9. If they are not equal, then go to L3. Okay. So that is the reason. Clear? Is this point clear? Please tell me. This is clear, right? RAW dependency. How to find RAW dependency? Now you tell me about WAW dependency. What about WAW dependency? So you can notice that we have WAW dependency here. So there is a WAW dependency between 1, 3. This is a WAW dependency. Okay, what about the next? Okay, what about the next? You are writing R8. There is no one else who is writing R8. That's it. This is the only one, right? Yes or no? Because no one else, see, you are writing R8, but no one else is writing R8. You are writing R3, no one else is writing R3. You are writing R9, no one else is writing R1. So there is only one WAW dependency. Understood? Only one WAW dependency, only one. That is L1, L3. What about this next one? What about WAR dependency? Tell me, how many WAR dependency? So WAR dependency, you have to check like this. See, there is no WAR dependency. Yes, there is a WAR dependency. Just go in the reverse. See. Just check in the reverse direction. Just check in the reverse direction. Just check in the reverse direction, nothing else. Just check in the reverse direction. Okay, just check in the reverse direction. That's it. So just check in the reverse direction. No, sorry. Actually, they are not writing. So always check in the reverse direction. They are not even writing. Here you have no right. Here you have no right. So there is nothing to check here. So there is nothing to check here. You don't have to check anything here. Just check, is there anyone reading R9? Just check, is there anyone reading R3? Is there anyone reading R8? That's it. So there is only one WAR dependency. Okay. Clear? Please tell me. So far, everything is clear. Now let's see data hazards. So what are the data hazards? This we have already seen. some dependencies can create data hazards. Do you remember this now the pipeline matters. Okay, remember now when you are checking data hazard, how to check that data hazards, how to check that some dependencies. So data hazard, they are property of code plus pipeline. They depend on code plus pipeline. They will depend on this. Okay, so basically they will depend on code plus pipeline. They will depend on the code also, they will depend on the pipeline also. Okay, so what are the data hazards? How to check? I already told you how to check if some dependency is, how to check if some dependency is hazard in a pipeline. How to check that? Anyone? I told you in the last class how to check if some data dependency is hazard in a pipeline. How to check? Just do normal execution. Just do normal pipeline execution and check if any problem. Okay, and check if any problem. Is this clear? Just do normal pipeline execution, you do, and then you check if there is any problem. That's it. Okay, so let's do this now. Let's do this. Take your copy pen, please. Take your copy pen. I am asking you some questions. Okay, there are some beautiful gate questions on this topic. Please take your copy pen and tell me. This we have already seen. Do you remember? Do you remember that this dependency will create a problem? Okay, this RAW dependency will create a problem. This we have already seen in the last class. This RAW dependency is a hazard. Is a RAW hazard in MIPS pipeline, right? Yes or no? In MIPS pipeline, correct? This RAW dependency is a hazard in MIPS pipeline. This we have already seen before in the last lecture. In the last lecture, this we have already seen that this RAW dependency is a row hazard, is a RAW hazard in MIPS pipeline. Okay, what about this one? Take your copy pen and tell me. What about this one? What about this one? Assume that you have MIPS pipeline. I'm asking for this one. I'm asking for this one. Is this hazard? Is this RAW hazard on MIPS pipeline? Because I have to give you pipeline, right? I have to give you pipeline information. I have to give you this information. I have to give you pipeline information. So is this RAW hazard in MIPS pipeline? Make this assumption that in any cycle, the register read will happen. Assume that if this is your cycle, assume that the write will happen here. The register write will happen in the first half of the cycle, and register read will happen in the second half of the cycle. Now you tell me. Okay, assume that register write will happen in the first half of the cycle and register read will happen in the second half of the cycle. With this assumption, you tell me the answer. With this assumption, you are going to tell me the answer. Is this only focus on this? Is this dependency only focus on this dependency? Okay, just focus on this dependency. You only have to focus on this dependency 1,4. Okay, so let's check it out. Let me check it out. So you have cycle C1, cycle C2, cycle C3, cycle C4, C5, C6, C7, C8. Okay, so tell me, you have, okay, the instruction I. Okay, so let's assume that instruction I1. In cycle C1, let's directly start from where? Let's directly start that it was in the execution stage. It was in the execution stage. Let's assume. Let's directly start from there. Like there were some other cycles, but let's directly start here. It was in the execution stage. Or maybe, okay, so let's do it completely. Okay, let's do it completely. Instruction fetch, instruction decode, and here you are in the execution stage. Now, where is I2? See, if you only have to focus on these, let's just focus on these. Let's only focus on this and this. Okay. Just focus on I1 and I4. So you tell me when this will read R1, when this R4, like you can notice that. Are you getting my point? See, focus on this instruction I4. When this instruction I4 is in the decode stage, let me assume that here instruction I1 is in the decode stage. Then where is the okay, because maybe you will not understand like this. So let me just write it completely, but let me write it small. Let me write it completely. C8, C9, C10, C11, and so on. Okay. So let me write it completely. Let me write the instruction execution. I1 hai, I1 is there, I2 is there, I3 is there, I4 is there. Okay, let's quickly do this. So you have instruction fetch, then you do instruction decode, then you execute, then memory access, then write back. Similarly, in the C2, this is instruction fetch, this is instruction decode, this is execution, this is MA, this is WB. Here, this is instruction fetch, instruction decode, execution, MA, WB. And then finally, this is instruction fetch, instruction decode, execution, MAWB. Okay. Now only focus on this and this. Now only focus on this and this. So when you are reading at that time, is correct value available? When you are reading at that point of time, is the correct value available? Is the correct value available? Is the correct value available? Tell me. Is the correct value available? Remember, this is writing R1 and this is reading R1. Is the correct value of R1 available for I4? Yes, it is available, right? Because I already told you that in the between, like in the half of this, the register R1 correct value will be available. Yes or no? The R1 correct value will be available. Correct or not? Yes or no? R1 correct value will be available. So it will read here. So it will read correct value. So I4 reads correct value. So I4 reads correct value. So there is no problem, right? In the next cycle, it can go to execution. In the next cycle, it can go to execution. Did you see there is no problem? Did you see because of this dependency, there is no problem? So is this row hazard? The answer is no. This is not a row hazard. Clear? Is this clear? Please tell me. But if I give you the same question, I give you the same question without split phase. The same question without split phase, like with same question without split phase. Now tell me. The same question without split phase. Then there will be hazard. Then this is going to be hazard. Then this I1, I4, this will be row hazard. Then this is going to be row hazard because in this situation, what will happen? This is your C5. This is your write back. So you can make the drawing like this. The R1 correct value will be at the end of the cycle, right? Yes or no? R1 correct value will be at the end of the cycle, at the end of the cycle. So what it means? It means that you cannot read. It means that if you read a wrong value, it means you are reading a wrong value. So in the next cycle also you have to stay. That is a bubble. Then you can go to execution phase. Okay? Clear? Is this crystal clear? How to check hazard? How to check if a dependency is hazard or not? Is this crystal clear? How to check if a dependency is hazard or not? Is this crystal clear? Please tell me. Let's see this question. A beautiful question. Pipeline is changed. We have changed the pipeline. Okay? We have changed the pipeline. Now tell me. But did you notice that some RAW dependencies are hazard, some not? Yes or no? Some RAW dependencies in any pipeline, some RAW dependencies are hazard, some are not. Correct? In any pipeline, whatever pipeline you take, I can say that some RAW dependencies are hazards, some not. Agree or not? Yes or no? Some RAW dependencies will be hazard and some will not. For example, in the previous example, can I say, if you have, can I say, if you have this type of situation, and let's assume there is, this is I5, or maybe, okay, then can I say that this dependency will like between this and between this, if you have more than 3 instruction, if you have greater than or equal to 3 instruction, then can I say that this will never be a hazard? This dependency, this is a dependency. This dependency is never a hazard. Can I say? Please tell me. Can I say that this row dependency is never a hazard? If you have greater than equal to 3 instruction in between. Understood? Let me know. If you have greater than equal to 3 instruction in between. Just think about it. Let me tell you. Okay, let me tell you, like if you have instruction I1, it is writing something. And then you have 3 instructions. Instruction I2, instruction I3, instruction I4, and then instruction I5. And this instruction I5 is reading something, reading R. Now you can notice this, look at this. This is a dependency. This is a RAW dependency. But let me prove it that this will never be a hazard. You can easily see in our pipeline. This is our pipeline: instruction fetch, instruction decode, execution, memory access, write back. Just think about it. Just think about it. If I5 is here, then where? Or I can say, okay, just think about it and tell me. When I1 has gone, then this I5 will come into the decode stage. Yes or no? This I5 will come in this stage when this I1 is already gone. Yes or no? When this I1 is already gone, in this situation it will happen. Means I1 is already gone. I1 is already gone. So did you notice that it will always read the correct value? So this will always read the correct value because I1 is already gone. So this correct value is already available. So I can say that I5 reads correct value. Agree? Do you agree that when this will be in the decode stage, when this instruction, this I5 instruction, when this will be in the decode stage, then I1 is already gone when it will come to the decode stage. When this instruction will come to the decode stage, then I1 is already gone. Because I1 is already gone, so this value is already available. This correct value is already available. So this instruction will read the correct value. Okay, understood? So this is what I'm saying, that in any pipeline, some RAW dependencies will create hazard, some will not create hazard. For example, can you solve this question? Can you solve this question? With respect to this I1, with respect to this, are these dependencies or these are hazard? This is what the question is asking. Tell me. This is what the question is asking. Are these dependencies or are these hazards? The pipeline information is given to you. There are 3 stages. In the first stage, we fetch and decode. In the second stage, we read the register and we use the ALU. And in the last stage, we read the memory and we write into the register. Okay, take this question. Please solve it. Take 1 minute. For these 3, you tell me, are they dependency? Are they hazard? Hello. Yes. So please tell me. So you can notice that definitely, definitely these all of them are what? All of them are dependencies, correct? All of them are RAW dependencies. All of them are dependencies. There is no problem in that. Okay. But what about hazard? So you notice, first of all, let's check it about this. Okay. See, when this addition is here, just look at this. When this addition is here, then where is the subtraction? When the addition operation, see, when the addition operation is decoding, sorry, when the addition, focus on when you are reading the register, focus on when you are reading the register. So when the addition is reading the register, then where is subtraction? Sorry, when the subtraction is reading the registers, when the subtraction is reading the registers, the subtraction is reading the registers, then where is the addition? Then here is the addition, correct? Do you agree? Okay. When the subtraction is reading the R1, when it is reading the R1, then this addition is writing. Okay. Now, there are two conditions. Please understand, there are two conditions. If you assume, split phase, then what happens? If you assume split phase, if you assume this type of situation, that in a cycle, if you assume this type of situation, if you assume this type of situation, that in the first half you read the register, and in the second half you write the register. In this situation, in the first half you are reading the register, in the first half you are reading the register, means there is no split phase, then definitely this wrong value you are reading, the subtraction is reading the wrong value, right? Do you agree that this subtraction operation is reading the wrong value? So that is the hazard. Now the same question I am asking, if I change this and then I give you that in the first half you are writing the register, and in the second half you are reading the register. Now tell me, in the first half you are writing the register, in the second half you are reading the register. Now tell me, now this will not be hazard, right? Yes or no? Because in between the value will be available, yes or no? Is this clear? In between the value will be available. So in this situation there will be none of them a hazard in this situation. So basically this is the condition of split phase, as I told you. So if you assume this split phase, is this understood? Please tell me, let me know. See, I am just giving you the complete analysis. I am giving you of everything. Slowly, every point I am telling you. You tell me this is called split phase. So if you assume this split phase, then there is no hazard. But by default, never assume split phase. This is just my suggestion. Okay, because in the Hamacher book also they don't assume it. In the Carl Hamacher, that is a standard book, that is the best, I can say, that is most referred in the NPTEL lectures. Okay, by IIT, ISC professors, they also refer Carl Hamacher. So that is the reason. Don't assume split phase from your side. Do not assume split phase. So in this situation, this will be hazard. But this will never be hazard, right? This will never be hazard, correct? Okay, why? Because the reason is very simple. This is never going to be hazard, because when division is reading the register, where is addition? When division is reading the register, where is addition? When division is reading the register, where is addition? Where is addition? That is already completed. That has already gone. So you are reading the correct value or not? Division is reading the correct value or not? Of course, it is reading the correct value. So these are not hazards. This question is clear to everyone? So just focus on, basically just focus on where you are reading and where you are writing. Just focus on in which phase you are reading, in which phase you are writing. Okay, clear? This question is clear. Now let's move on. In this question, tell me how many RAW hazards are there? A very beautiful question. This question I gave you in the test series. In the All India Mock Test 2, this question was there. How many RAW hazards? How many RAW hazards in MIPS pipeline? How many RAW hazards? How many RAW hazards in MIPS pipeline? First of all, how many RAW dependency? Can you tell me? What is the number of RAW dependency? First, you tell me the number of RAW dependencies. How many? So number of RAW dependencies are 1, 2, 3, 4. Total 4, right? Okay. So that will be total 4. Okay. Now you tell me how many RAW hazards. This question I gave you in the All India mock test 2. This question was there. I was asking how many RAW hazards are there. This same question, as it is this question I gave you. This is a standard question from the Washington University. Beautiful question. Number of RAW dependency you have, that is 4. How many RAW hazards are there? Can anyone tell me? Swagtendu, can you solve it now? In the All India mock test 2, you skipped it, but can you solve it now? Mavit, can you solve it? Arnab, Sudeep, KS, Debanjan, Abhishek, K, Mr. K. So please try this. Don't assume any split phase, okay? Do not assume split phase. I told you by default, never assume split phase, okay? Okay, let's solve. So before we solve this, let me tell you that never assume this split phase from your side. Like by default, okay. Now let's come back to this question. See, this is a beautiful and very simple question actually. A very simple question. See, let's solve it. Very simple question. Let's solve it. So you have C1, C2, C3, C4, C5, C6, C7, C8, C9, and so on. Okay, very simple. So you have add instruction, right? Correct. See this add instruction. So let me write it. Okay, how to check? Okay, what I should do? Just tell me simple thing. What should I do to check if something is hazard or not? I know there are 4 row dependencies. This is what I know. I know there are 4 row dependencies. This is what I know. Total 4 row dependencies are there. How to check if they are hazard or not? How to check? What should I do? Normal execution, add, subtraction, and or XOR. Okay. So you know that add, subtraction, and or XOR. So for the add also, normal execution you do. That's it. Okay. Just do the add, subtraction, and just flow through the XOR. Just flow through the pipeline. So you will go to instruction fetch, then you will go to instruction decode, then you will go to execution, then you will go to memory access, and then you will write back. Okay. Next, this instruction, it will go to instruction fetch. It will be so in the cycle C2 we will fetch subtraction, then we will decode it and read the registers, then it will go to execution phase, and then it will go to MA phase, then WB phase. Similarly this AND, it will go to instruction phase, then ID, then EX, then MA, then WB. Similarly this OR, it will go to instruction fetch, instruction decode, execution, MA, WB, instruction fetch, instruction decode, execution, MA, WB. That's it. That's it. Now. Okay. Now you tell me where this R1 correct value is available. Where at what point of time this R1 correct value is available? This R1 correct value is available here. At end of C5. After C5, very good. Okay, at the end of the C5, this R1 correct value is available here. So who is reading the wrong value then? Okay, this person is reading here, this person is reading here, this person is reading here, this person is reading here. Okay, these are the people who are reading. These people are reading. So tell me, who is reading the wrong value? See, this person is reading here, this person is reading here, OR operation is reading here, XOR operation is reading here. Who are reading the wrong value? So you can notice that this value will be available here. Remember, simple point. This value will be available here. Here the correct value will be available, but you are reading the wrong value. You are reading the wrong value. You are reading the wrong value, but you are reading the correct value. Okay, you are reading the correct value, but you are reading the but these people are reading the wrong value, wrong value, wrong value. So how many data hazards? Tell me how many data hazards, how many dependencies are hazards? How many dependencies are hazards? Total 3. The answer is 3. Okay, so for this question the answer is 3. Tell me, this question I put in the Go Classes test series, and isn't it simple? If you know the concept in, okay, just tell me, if in the gate exam, if this question or similar question comes now, will you skip it? Will you skip it? You can very easily do that, right? In Go Classes All India mock test, this type of questions are there. If you know the concept, see, it's not only about like, if you truly understand the concept, you can solve it, right? This question that I solved, this question, only if you have true understanding, if you have correct understanding, then you can solve. Correct? Yes or no? So you can notice, you can read this. So read this. Only 3 hazards are there. Only we have total 3 hazards. So simple question, right? Okay, that's it. So let's move on. So I have told you everything. Not all data dependencies are hazards. But can you prove that RAW dependencies are never hazards? Let me give you a question. Prove that WAR dependencies are never hazard in MIPS pipeline. In our MIPS pipeline, these are never hazard. Or actually, not only MIPS pipeline, basically you can take any single issue pipeline. Any single issue pipeline you can take. So can you prove it? Let me prove it. See, the proof is very beautiful proof. Let me give you it. Let me tell it to you. Okay. See, consider this. Let me give you RAW, like consider this I1, and let's assume that it is reading R. Okay. You are reading R, then you are putting into something like this you are doing. And here you are writing into R. Okay. Okay. Now you tell me, will it create any problem? Just check it out. Just check it out. Okay. On the MIPS pipeline, will it create any problem? This is your WAR dependency. Okay. Is it hazard? Just check it. You will see the proof. You will automatically see the proof. Is it hazard? Just check it. Is it hazard? Let's check it. So you have instruction fetch, instruction decode, instruction execution, memory access, and then you have write back. Okay, so you tell me, will it create any problem? It will never create any problem. See, it is never going to create any problem. Swagtendu, tell me, did you see the proof? Did you see that these dependencies can never create any problem? These dependencies are never creating any problem. C1, C2, C3, C4, C5, C6. See, look at this. This I1, look at this instruction I1. Instruction I1 is going to instruction fetch, then instruction decode, then execute, and then memory access, and then write back. This instruction I2, okay, it is going to instruction fetch, it is going to instruction decode, execute, memory access, write back. Okay, is there any problem? Tell me, is there any problem? See, we do not have any problem, right? Where it will read, where I1 will read, I1 will read here. Okay, I1 will read C2, I1 will read in C2, and I2 will write where? I2 will write in C6. So is there any problem? Okay, is there any problem? I1 should read before I2 writes, and that is happening, right? Yes or no? That is happening. That is happening. So there is no problem, never a problem. Similarly, can you prove WAW? Can you prove WAW dependency can never be a problem? Can you prove it? Can you prove it that this can never be a problem? Let me like, okay. So let's take I1 in which you are writing into R something you are writing into R. Let's assume you are writing something into R. Okay. So look at this dependency. Look at this. So this is a WAW dependency. This is your output dependency. Is this hazard? Is it hazard? This dependency, is it hazard? Again, you can easily see C1, C2, C3, C4, C5, C6. Again, you can easily see it will go to instruction fetch, instruction decode, execute, memory access, write back. Okay, it will go to instruction fetch, instruction decode, execute, memory access, write back. Okay, where it is writing, where I1 is writing, tell me. Where I1 is writing? Where I1 is writing? I1 is writing here. Where I2 is writing? I2 is writing here. Is there any problem? Everything is as perfect. Everything is perfect, right? I1 should write first, then I2 should write. That is happening. Here I1 writes, here I2 writes. So everything is perfect. Is this hazard? The answer is no. That's it. The data depends. So everything is fun now. Now are you afraid of dependency versus hazard? Is this crystal clear? Like whatever they give you, can you find out something is hazard or not? Some dependency is hazard or not? Which dependency is hazard? How many hazard? Okay, everything. Like, please tell me. Let me know. Is everything crystal clear? Like whatever variation they give you, can you handle it? Okay. So that's it. This is your chapter. That's it, nothing else. So these are the chapters. So you can notice not all data dependencies are data hazards. WAR hazards are never sorry, these dependencies are never hazard in a single issue in order pipeline. What in order means? What in order means? In order means that all the instructions are going through all the stages. Okay. What this in order means? This in order. What this means? This means that all the instructions are going through all the stages. Okay. Is this clear? All the instructions are going through all the stages. Every instruction will go through all the stages. This type of pipeline is called in order pipeline. That all the instructions, they are going through all the stages. Even if you don't need, like for example, let's assume addition instruction, does it need data access memory? Data memory access? Addition instruction, add R1, R2, R3. Add R1, R2, R3. Does it need data memory access? No. But still, it will spend that time. Yes or no? That time, it cannot skip it. Right? Yes or no? Sudeep, Swagtendu, it cannot skip it. You cannot skip the stage. Skipping the stage is not allowed. Okay, so that's it. So finally, you can notice that this in order means every instruction goes through all the stages. In order means every instruction goes through all the stages. Every instruction going through all stages. Okay, that's it. So this is your chapter, and uh, oh, some more things are remaining. Okay, some more things are remaining, but now I am a bit tired. So shall we continue tomorrow? Some very few things are remaining actually. Some data hazard solutions we need to see, gate questions we need to see, and also control hazard. Okay, so let's continue tomorrow. Okay. Hmm. So far everything is clear. Like we will continue. Don't worry. I will give you the solution of hazard, data hazard. How can we handle the data hazard? What are the solutions possible? Hardware solution, software solution, compiler solution. All these solutions we will discuss. For every solution, we will take one gate question. We will take, and then we will study the concept of register renaming. Okay, this concept, register renaming concept, we will see, and then we will go to the control hazards. Okay, so tomorrow we will continue. Okay, thank you.